Okay, so let's say you want to find the inverse of this matrix, okay? The formula for the inverse of a matrix is the following. So if I have A, B, C, D, its inverse, which is denoted by to the power of -1, is equal to 1 over the determinant. So if this is matrix A, you know it's the determinant of A, whatever that determinant is, times, and then we're going to flip-flop these diagonals, change the sign of the other two diagonals. So you're just going to have to memorize that formula, okay? You take the determinant and you do 1 over the determinant, you flip-flop those numbers and change the sign of those numbers. So if I come over here and do this one, the determinant of that is 5 minus a -12, which is 17. So I'm going to start with 1 over 17. Okay? Then I'm going to flip-flop the 5 and the 1. So 1 goes there and 5 goes there. And I'm going to change the sign of the 6 and the -2. So I'm going to make it a -6 and a +2. Okay? So these two matrices are inverses of each other. So what does that mean, you might ask? Well, let's talk about that. Let's say we multiply this inverse by the original matrix. Let's keep this 1 over 17 out in front. We won't deal with fractions yet. So we're going to multiply this by this. So 1 times 5 plus +12. 5 plus 12 is 17. Then I'm going to take this row and this column. So that's a +6 plus a -6. That's 0. Then this row and this column. 10 plus a -10 is 0. And 12 plus 5 is 17. Now I'm going to multiply this fraction through this matrix, and I get 1, 0, 0, 1. That is always what happens with an inverse. When you take a matrix times its inverse, you get this. This is called the identity matrix. All identity matrices have 1s down the diagonal and 0s everywhere else. So this is the 2 by 2 identity.